Equitome. Voice of the web. Corpus-based generation of harmonic progressions using controlled Markov selection. This the webpage of the Corpus-based harmonic progressions generator presented at the first International Conference on Computational Creativity ICCCX in Lisbon, Portugal in 2010. The system was developed in Max/MSP by the directors of the MAMAS Lab, Professors Arnie Eigenfeld from the School of Contemporary Arts and Philippe Pasquier from the School of Interactive Arts plus Technology at Simon Fraser University in Vancouver, Canada. Description: utilizing the unique method for quantifying harmonic complexity and tension between chord transitions in a corpus of MIDI files, the style imitative chord progression is generated which closely matches the three-dimensional vector specified by the user. In this way, employing a Markov model and case-based analysis of the selected material, the system generation offers a balance between user-requested material and coherence within the database. By following the tabs above you will find all the information necessary to download, install and run the system. To download and install Corpus-based generation of harmonic progressions using controlled Markov selection. There are 3 versions of the system. The patch version is open, platform independent and must be run using Max/MSP. The collective version runs under the Max runtime environment which would also run the patch version but without the possibility to edit the patch. The application version runs on its own without the Max runtime environment and is not modifiable. This version contains an embedded Max runtime environment and so is self-contained but much larger. Max/MSP patches platform independent. Download patches includes the generation and analysis patches, a set of prepared media files and the database of processed files ready to use. Install. If you do not already have a running version of Max/MSP you can download a 30-day fully functional demo version here. Required third-party externals. There are 2 external libraries that need to be installed. You can find the download and install instructions for each package corresponding to your platform in the links below. Objects by Peter L. Cia, University of California, Santa Cruz. Jazz by January C. Shocker, Zurich University of the Arts. Once you have Max/MSP running with the above externals you will need to copy the folder named Arnie Media Parser which is inside the zipped file into the cycling 74/Java/classes folder. You should now be ready to use the patch. Standalone application. Download. Mac OS X, application/collective. Windows, application/collective. Includes the generation and analysis patches, a set of prepared media files and the database of processed files ready to use. The Windows analysis patch may have incompatibilities due to a bug with the drop file object on Windows 7. Install. The collective version will run using the Max runtime which is free and available here. You will also need to copy the folder named Arnie Media Parser which is inside the zipped file into the cycling 74/Java/classes folder. The application version will run as is, without Max/MSP or the runtime. 3 Tutorial. Corpus-based generation of harmonic progressions using controlled Markov selection. This tutorial explains how to use the harmonic progression generator and the process for customizing and adding songs to the database. For a more in-depth description of the system we refer you to the publications linked at the end of the tutorial. You can also download a PDF version of this tutorial here. Using the harmonic progressions generator with the embedded database. Adding songs to the database using correctly formatted media files. Details on formatting media files for adding to the database. Publications. Using the harmonic progressions generator with the embedded database. The system utilizes a methodology to generate progressions consisting of Markov conditional probability distributions, using either first, second, or third order chains. These distributions are derived from transitions between chords in the corpus selected by the user. However, rather than allowing the generative algorithm to freely choose from the derived transitions, user-specified vectors, suggesting baseline movement, harmonic complexity, and voice leading tension, are overlaid in order to stochastically choose from the best matching solutions. When selecting the song too low, consider that the nature of the user-selected database will greatly influence the generation. Variety in generation depends on the number of transitions and number of possible transitions, as well as the probability distribution over these possible transitions. If a corpus is heavily redundant, there will be limited variety in the output. On the other hand, selecting the corpus from two composers of very different styles will result in a small intersection of transitions, especially within the higher order transitions. The generated progressions will tend to consist of material from one composer or another, with any transitions between the two occurring only when a change from the intersection of the databases is stochastically selected. Loading analysis data. Select the song from the drop-down menu. After processing each selection, there will be new transitions added to the Markov database, generating the chord progression. Once the transition tables have been generated for the specific corpus, harmonic progressions can be generated using the mixture of stochastic choice and user request. An initial chord is selected using weighted probabilities from the array of starting chords. First, create dynamic shapes in the target section for baseline, complexity, and tension, as well as the weight for each parameter in choosing from the database. Here you also have the option to set these vectors automatically by clicking on the Select Phrase from Database button. In this case, the baseline is weighted the highest. This will give this selection priority over the other vectors indicated. Notice that the user-defined vectors influences the selection from the Markov transition tables, but there is no guarantee that the actual generated progression will match the user vector. This is due to the available values within the tables and the Gaussian selection from those values. For example, the following figure displays the user-defined baseline, and the resulting third-order generated baseline, using a 4-song database containing 64 chains and a requested phrase length of 8 chords. A larger database will result in a closer approximation, due to the potentially greater available choices. Lastly, the request may not, and need not, be in the style of the corpus. The result will be a stochastically chosen correction of the request given the actual corpus. The user-defined vector, left, and generated baseline, right, given a 4-song database. Specifying the phrase length. Each phrase has a user-specified suggested length. During chord sequence generation, once the generated length reaches 75% of this value, the algorithm begins testing if the last 2 chords generated are in the cadence array. If the test returns true, the phrase generation algorithm exits. Here in the second pane you can select the number of bars and the range of chords desired for the generation algorithm. In this case, the algorithm will attempt to generate 16 bars, with between 8 to 16 chords. Lastly, generate the phrase by clicking on the Generate Phrase button. The progress will be displayed. If the system is unable to satisfy all the requirements specified by the user, which can be seen as a set of constraints using the current Markov transition table, an error is returned. In this case, you will have to either try again, add more songs to the Markov for analysis. This will increase the transitions available or change the bars and number of chords required. When complete, the phrase will be displayed. Listening to the generated chord sequence, first check that the DSP button on the top right corner of the playback transport is on. Then click on the rewind button.